Hello everyone. We are together again for a new session, and today we will discuss the important topic, which is Maxwell law of molecular velocity. In this lecture, we will discuss the different um, content. First is introduction. We will discuss the introduction of Maxwell law about the molecular velocity. At number second, we will discuss the Maxwell distribution equation. And at number third, we will discuss the effect of temperature by increasing the temperature or decreasing the temperature. What will be the effect on the molecular velocity? And we will discuss the point of view of Maxwell. And at lastly, we will discuss the most probable velocity of a molecule. We will start from the introduction. In introduction, we will discuss is we know that the kinetic theory of the gas molecule, there are a large number of the particle are in random motion, and each particle has different speed, and collision between the particle will be change of speed of the particle. During collision they exchange their kinetic energy and their speed due to their different size of these particle. And if we plot a graph, the number of molecules whose velocity fallen with a series of narrow range, then we would obtain a slightly asymmetric curve, that is velocity distribution, and that peak of this curve would correspond to the most probable velocity. At the end, we will discuss this important velocity, which is most probable velocity. If we talk about the Maxwell equation, we know that in a container, the gas molecule moves in with different speed. For example, some particle moving with the speed u1, and some particle are moving with the speed u2, and similarly they are moving with u3 and u4 up to infinity velocity. So the total number of the gas molecule is represented by capital N. Then their du is a velocity is equal to change in number of change in number of gas molecule for the unit velocity range. That equation will be range will be dn over du. So the fraction of molecule also equal to dn over n du. Then the equation dn over du is equal to Boltzmann a term like 4 pi m over 2 pi rt 3 by 2 u square e की power minus u square over 2 rt. So in other in explanation of the Maxwell law of molecular velocity, the velocity distribution depend upon the temperature and mass. At a higher temperature allows at a higher temperature, the large fraction of a molecule have attain greater amount of kinetic energy, and that curve will be shown in the graph. At a higher temperature, the fraction of a molecule going to in flattened form. But at lower temperature, the molecule has less energy. Therefore, the speed of molecule are lower, and distribution has smaller range. Is a molecule, is the temperature of molecule increase, then the distribution flatten out, and because the molecule have greater energy at higher temperature, so the molecule of a gas are moving in fast. So this is graph between at a different temperature like 100 Kelvin, 200 Kelvin, 300 Kelvin, 500 Kelvin, 700 Kelvin, and 1000 Kelvin for the nitrogen gas. So the nitrogen gas molecule have such type of curve at 100 centigrade, the molecule show the fraction in that form at 100 Kelvin, and it's going to be flattened at 200 form, and it's going to more flatten at 300 degree 300 Kelvin. Similarly at 5 and 7 and at 1000 Kelvin, it's these molecule going to be in more largest flatter form. And if we talk about the effect of temperature in simple graph, we can say that if when we increase that temperature, then their fraction will be decreased. Fraction of a molecule will be decreased. If the at a lower temperature, the fraction of molecule having large fraction, or we can say that at low temperature the fraction large number of particle move with the speed, medium speed. You can see in the graph that is a range about the medium speed. So we can conclude that it average speed, its medium speed, a lot of fraction of a gas molecule are moving, but when temperature increase, then the fraction of molecule will be decreased, and their velocity will be also increased due to increasing of the temperature. So the peak of the curve downward, and it become flattened. So the increase of temperature, the value of most probable velocity is also increase, and the fraction of molecules having most probable velocity decrease with the increase of temperature. If we talk about the effect of mass, so when heavier molecule, on the average, heavier molecule move slowly than lighter molecules. So the heavier molecule have will have a smaller speed distribution, while lighter molecule have a speed distribution that is more spread out. You can see in the graph heavier molecules, some like that oxygen molecule, their distribution is lower, and similarly for the nitrogen is also lower, and helium, hydrogen and helium has more flatten in the graph. So in the conclusion we can say that if the gas molecule has smaller velocity, smaller size, then have smaller size, then their spread distribution is smaller. But the heavier molecule has smaller speed distribution, but the lighter molecule have distribution is more. So these are two conclusions. The smaller molecule or lighter molecule have distribution is greater, and heavier molecule has smaller distribution of the velocity. From the graph, we have found it two or three things, which is that the fraction of molecule is zero, having zero velocity is also zero. You can see in the graph the at zero velocity there is no fraction of a molecules, and when velocity is increased, then the fraction of molecule is also increased. So we can say that the fraction of molecule is zero, having velocity is also zero. This second point is that the fraction of molecule is increased, having velocity is also increased till the reach the peak at particular velocity, and being to decrease. For most probable velocity, we can say that velocity with which maximum number of particle in a gas move at a constant speed. And if we talk about the graph about the most probable velocity, here is a maximum number of molecule having velocity v, so we can denote it by most probable velocity by vp. You can see, we can see the graph. It can be the most probable velocity. You can see the equation for that is equals is 2 kt over for the average velocity, and root means square velocity we will discuss in next videos.